Hello everyone, welcome back to another daily AP Physics 1 practice problem. Today we have a work and energy problem from the MIT AP Physics 1 workbook that will be in the description down below for you guys to follow along. And with that being said, let's go ahead and read the question. It says, a softball player catches a ball of mass m, which is moving towards her with horizontal speed v. While bringing the ball to rest, her hand moves back a distance d. Assuming constant deceleration, the horizontal force exerted on the ball by the hand is, and then you have our answer choices. So here is we're going to need to use some background knowledge of Unit 3. And I know I made these videos before. I uploaded the Unit 3 unit review, but that will be out shortly this week. Sorry that I've been postponed with a lot of stuff. There's been a lot of stuff in my personal life coming up, but I will make sure to get these video out as soon as I can. And with that being said, the one thing that we need to know for this equation is, since it's asking us what the horizontal force is, and here we can recognize by looking at this equation, this looks like something related to energy, because we can see this mv squared, and if we remember, kinetic energy is equal to 1 over 2 mv squared. We're going to need force, and the only thing that is force related in energy unit is going to be work, because work is equal to the force times the distance times cosine of theta. And knowing that, we're going to go ahead and calculate what this value of the force is. And the one thing that we need to know for this question is that work is also equal to another thing. Work is also equal to the change in kinetic energy. And this equation right here is going to come in handy in this problem. The reason being, we know that the ball was initially traveling with the horizontal speed of v, and then we know that it's going to come to a rest, meaning that the v final is going to be 0. So setting up this equation, we're going to get that work is equal to delta k, and delta k is going to be 1 over 2 mv final squared minus 1 over 2 mv initial squared. And then work, we can just write this force times distance times cosine equation, because that's what we want to find the force. So force times distance times cosine of theta. And here we could isolate and solve for cosine, but I would like to just simplify everything at first. That's just one thing I like to do, but just plugging in our values that we know. So we know that v initial is going to be equal to v, because right here it says horizontal speed of v. We know that our mass is just going to be m, since it says right here ball of mass m. And then we know that v final is going to be 0, because right here it says ball to rest. And then we know that the force is going to be what we're solving for, so force is equal to unknown. The distance is right here, moved back a distance d, so d is just going to be d. And then we need to know now what the theta is. So to find out what theta is, we're just going to find what the angle of the force between the movement. So here we know that the ball is coming this way, right? And here we can have the softball player's hand. Once the ball comes in contact with the ball is going to keep moving. Um, right here, her hand moves back, so the ball is going to move. Um, it's going to move this way, actually. So because as the ball's pushing on it, it's going to move in the opposite direction. So we know that the force is acting this way, but it's going in the opposite direction. So to find the degree behind this, we're going to go ahead and find the angle, which is going to be this big angle. And since this is a straight line, this angle is going to be, if you remember, 180 degrees. So we can go ahead and plug in 180 degrees into our equation because they are in the opposite direction. So that's going to be theta is equal to 180 degrees, and just plugging that into the equation, we get that force times distance times cosine of 180 is equal to 1 over 2 m0 squared minus 1 over 2 m, that's m v1 squared, or not v1, v squared. Now we can simplify this. This 1 over 2 m0 squared, this is just going to all become 0. And then this cosine of 180, if we remember our unit circle, this is going to be 90 degrees. Right here is going to be 180. And this is 1, 0, -1, and 0. And this is all based off cosine right now, because this would have been 0, this would have been 1, this would have been 0, this would have been -1. But right here, we only want the x because cosine is x. And if you don't remember this, don't forget you can use your calculator, but I just like to use the unit circle as a memory. So this -1 is going to be what we're going to plug in for our cosine of 180 right here. So doing so, we're going to get that force times distance times -1 gives us negative force times distance. So negative force distance is equal to 1 over 2 mv squared. And to get distance by itself, we can divide it by d and negative. So we're going to, oh, we also have this negative, do not forget. So we have a negative here. Dividing by negative d gives us force is equal to 1 over 2 mv squared. This is negative over negative d. This negative cancels out, that negative cancels out. And then to make this more, uh, as you could say, um, more beautiful, I guess you could say, you would take this mv squared and you could bring it to the top, since it's the same as multiplying by mv squared over 1. And that would give us over here force is equal to mv squared over, and then this 2 is in the bottom, dividing by the d, so it's also in the bottom, divided by 2d. And if we look at our answer choices, we can see that choice A, mv squared over 2d, matches up what we have right here, leading us to our correct answer. I hope you guys enjoyed the video. If there's anything you didn't understand or was complicated, please comment down below, and I'd love to answer those questions and make any additional videos you need. And as I said, I do apologize for not uploading lately and having being a little behind on my upload schedule. I will have these videos out by the end of the week. Just some things I have to take care of. But yeah, I hope you guys enjoyed the video. Continue your prepping, and remember to enjoy life.